to have might. Physics 101 is a don't let me start creating fear into your mind. But I have to invite some stuff about this Physics 101 I'm doing. I believe it's the hardest course. The faculty of science in the first semester and then Kingsmate, or what do you think? Physics 101.
Go on.
I said I'm just trying to give them some introduction about the course first. I believe it appears to be the hardest among all those courses.
Yes.
100 level for semester.
Yes.
So it's about some stuffs now that perhaps if we can keep having this lecture and after that maybe we can see people that will read very well. If you guys can go back because sorry, I'm not creating fear into your mind. This material is up to about 600 and something pages. I think we have one to be 311 and the other one is 328 pages. That's 639 pages. So this physics 101 course, the material, because physics 101 is elementary mechanics and it is elementary mechanics and what's the other one? So elementary mechanics and heat. That's what this one was. Heat first. After the heat, we start with mechanics. Inside the heat now, we're gonna cover some things actually. Some things here. White bulb. So I'm trying to let you know this now for you to know the type of energy you're gonna direct towards the course. You understand? So I want you to be able to know the type of energy you're giving this course. It's a 3 unit course, very, very important. And actually, people feel it. If you can read very well for it, prepare well for it, then definitely you'll be having a good mark in it, a good score. I wish everyone well, I wish you the best. So let's start from where it starts. I don't know. I always don't have the material with me. Physics 101, which is heat and temperature. That's the first module. Heat and temperature. First, is there anyone that can give me a definition of heat? Another one that can give me a definition of temperature? No, I'm gonna waste my time. Just let's forget about it. I'll waste my time now. We don't have much time to go. I'm coming. Sorry, I have to reply to a message very quick. So, when we mention heat and temperature, we all know what heat is normally as a layman or as laymen. You know what temperature is as laymen. But I want us to understand some concepts that there's a very big difference between these two things. People use them interchangeably, wrongly. Yeah, the interchanging fact about them is very wrong. You can't use heat for temperature or use temperature for heat. Temperature means something else, while heat means something else. Heat is just heat is due to a difference in temperature. Heat is due to a difference in temperature. So now when I say temperature, it means the degree. That is the first concept. It is the degree, the level or degree. Degree sounds too scientific. Forget it then. Say the level. If degree is too hard for you to understand, then believe that temperature is the level of hotness or coldness of a body. It is the level of hotness or coldness of a body. By this, I believe you should understand the type of degree I mean. So you can definitely say temperature is the degree of hotness or coldness of a body. I say again that temperature is the degree of hotness or coldness of a body. Temperature actually gives rise to what we call heat. Heat comes due to a difference in temperature. When a body is very hot, what do we say? It has a high temperature. When that body is cold, you say it has a low temperature. Now I'm going to ask this question. A water that is inside a water bath now and an ice block, a normal water bath, like the one you want to use in the bathroom now, and a normal ice block, which one of them is having a higher temperature? Ice block and normal water. Which one is having a higher temperature? Anyone? You can raise your hand first. Which one of them is having a higher temperature? I would like you just raise your hand and speak. Ice block. I'm not the one holding the phone. I'm just coming back to check. So I might not see what you write sometimes. So ice block, okay. Yeah, ice block is not having a higher temperature. You're wrong there. Mr. Joey Sticks.
Normal water.
So it is the ordinary water that has a higher temperature because ice block is 0 degrees Celsius and below. While ordinary water might be more than 0 degrees Celsius. It's even always more than 0 degrees Celsius. Might be around 10 degrees Celsius, 5 degrees Celsius, 20 degrees Celsius, and the likes. Don't let me waste much of my time here. I think I'll be able to explain all these things with you. So I'll be knowing the part of the I want to use my website to this time. So the first thing is temperature. So the temperature of a body changes by addition of heat or removal of heat. If it is applied to this marker now, the temperature changes, most especially when it is a metal. So ability of a metal to conduct heat, ability of a metal to conduct heat is known as thermal conductivity. Ability of a metal to conduct heat is known as thermal conductivity. Copper is very well. So all this thermal conductivity now, they have level. Thermal conductivity of copper is different from the thermal conductivity of brass, different from the thermal conductivity of iron, different from the thermal conductivity of silver, from that of aluminium and the likes. So now the measure of temperature, I would say the laboratory, we are doing an experiment that involves measuring the temperature. We call the measurement of temperature, we call it thermometry. When we are working with, in titrimetric analysis, all those titration, we are doing stoichiometry, we are doing volumetric analysis. So instead of, as we are calling that one volumetry too, we call this one thermometry. So we are doing volumetric analysis there. So this one too, we call it thermometric analysis, something like that. So that's thermometry. While the measurement of heat is known as calorimetry or calorimetry. So when we are measuring the thermometer, we are measuring the temperature. So the measurement of temperature is known as thermometry, while the measurement of heat is known as calorimetry or calorimetry. So the material, the apparatus in the laboratory or the instrument that is used to measure the thermometer, the heat, the temperature, the instrument used to measure temperature is known as the thermometer, while the instrument used to measure heat is known as the calorimeter. Please, are we getting that? With reactions, I would prefer that. I think we have just 3. With reaction, 1, 2, okay. 3 minutes, 2 people are getting. I said thermometer is used for measuring. Thermometer is used for measuring temperature. Thermometer is used for measuring temperature, while calorimeter is used for measuring heat. So there is now difference, or there are differences between temperature and heat. Heat is the measure of total internal energy of the substance. That is the definition of heat. While temperature is the degree of hotness or coldness of the substance. That's the first difference. What's the second difference? Heat is measured using a calorimeter, while temperature is measured using a thermometer. What is the third difference? The unit of heat was named after Sir Prescott Jones. So the unit of heat is known as joules, represented as capital letter J, joules, capital letter J, while the unit of temperature are about 3 or more. We have the Rankine, we have the Celsius, degrees Celsius, we have the degrees Fahrenheit, we have the absolute or Kelvin. So Kelvin as the unit of temperature, capital letter K, degrees centigrade or degree Celsius, that's degree Celsius. We have degree Fahrenheit, that's degree Fahrenheit. We have degree Rankine, that's degree. But as for the moment, just concentrate on Kelvin, degree Celsius, and degrees Fahrenheit. These are the units of temperature. While the unit of heat is joules. Joule is measured in heat. I will say, what's the amount of heat? You can say 5 joules. What's the amount of heat applied? 10 joules. What's the amount of heat applied? 20 joules. What's the temperature? 30 degrees Celsius. What's the temperature? 40 Kelvin. What's the temperature? 30 degrees Fahrenheit. That's what we mean by the unit. Are we getting that? Are we getting that too? All right. So now let's talk about the thermometer. Or look at the relationship between the scale sponge, the unit. The thermometer is an instrument used to measure the temperature of a substance or of an object. The temperature of an object is measured using the thermometer. The temperature of a substance is measured using the thermometer. So there are types of thermometer. Depending on what we want to measure, how to use them, and the most suitable way or method we can use for them. So now let us move together and please note what I'm going to write. I won't be too fast. Liquid in glass. We have the liquid in glass thermometer. We have the gas thermometer or constant volume gas thermometer. Together, we have the liquid in glass thermometer. We have the constant volume gas thermometer. Also, we have the bimetallic thermometer. We also have the thermocouple or thermocouple or thermoelectric thermometer. And also we have the resistance wire thermometer. We'll be analyzing this one by one. Perhaps we'll stop after getting to the picture. I'm going to explain them very well. Listen, I'll talk about the liquid in glass thermometer. It means there's going to be a glass with very thin wall. A glass with very thin wall. The liquid will be inside the glass. I'm going to explain what I'm doing here. Just want you to do with me very well. The liquid in glass thermometer is a type of thermometer. It is the one they use in the clinic to measure our temperature. It is the one they use in the clinic to measure our temperature. The liquid in glass thermometer. It consists of one or another liquid. They are just two liquids. Is there anyone that can give me any idea about except juristic? The liquids in liquid in glass thermometer. Yeah, not you, juristic. Not yet. Not you, Baba. Another person. All right. So by the end of this, session, you should have gotten that and you should have known it. There are just two common liquids. They are mercury and alcohol. Alcohol, gogoro, and mercury. So it's either the liquid in that liquid in gas thermometer, liquid in glass thermometer. It is either is mercury, it is either mercury or alcohol. It is either mercury or alcohol. I'm going to explain very well. So that's mercury in glass thermometer. How will it be mercury? Why mercury? I'll explain. And alcohol in glass thermometer. It is used in the clinic. We call it that clinical thermometer. The thermometer they are using in the clinic is known as the clinical thermometer. The thermometer they are using in the clinic is known as the clinical thermometer. This is exactly how it is. It has one thing here. Look at this thing I'm drawing here. Please look at the board very well. Look at this thing. You see that the level is not straight anymore. It is having a constriction here. So they call this thing kink. This is a common question. It's even I encountered this question in my last exam. Kink or constriction. Kink or constriction. It's a very prominent feature of the clinical thermometer. The clinical thermometer always has mercury in it. Oh, the alcohol. The alcohol in glass thermometer, they are used in the temperate regions, in some temperate countries. So that's where they are using alcohol in glass thermometer. Mercury in glass thermometer is what we use here, actually. So that thermometer, because it is used to measure human body here now, this clinical thermometer, you can see normal. What's the normal human temperature from anyone here? Normal human body temperature is what? Miss Ayomide, can you tell me? Human body temperature. Mr. Michael, Ms. Damilola, Mr. Chukuma, the normal body temperature is approximately 37 degrees Celsius. And I'm not even saying you still don't bother to bother yourself. Yeah, you're very smart one. Well, you said you just want to have something. Yes, said it. So wrote it. Wait it. Back in the map. People follow. So it's 37 degrees Celsius. 37 degrees Celsius. It's actually 36.9 degrees Celsius. And they approximated it to 37 degrees Celsius. So once you see somebody that is having more than 37 degrees Celsius, when somebody is having more than 37 degrees Celsius, that temperature is becoming high. When the person is having below 37 degrees Celsius, the temperature is becoming low. So now, there is no way a human body will become low in temperature, and it will be less, than 35 degrees Celsius. No, there is no way. It will never be less than 35 degrees Celsius. And there is no way it will be too high that it will be more than 43 degrees Celsius. That's why they believe somebody that is not healthy will have the range of 35 degrees Celsius to 43 degrees Celsius. But somebody that is very healthy will have 37 degrees Celsius approximately. That's why they label it like this. It has a very low range of temperature. A feature of the clinical thermometer. It has a very low range of temperature. It's not from 0 degrees Celsius to 100 degrees Celsius. No, it is from 35 degrees Celsius to 48 degrees Celsius. The range is just 8 degrees Celsius. Is there anyone that is getting me? So, I've said it that the alcohol in glass thermometer is not used in regions like this. They are used in the temperate regions. So now, why mercury? Why alcohol? They both have their advantages and they both have their disadvantages. Just that mercury is more preferred. So the mercury in glass thermometer, mercury is silvery in color. Silvery in color. So the advantages of mercury. over alcohol as the thermometric substance. It is the thermometric substance like that. Mercury is silvery in color, but alcohol is colorless. Mercury is silvery, but alcohol is colorless. So it being colorless means they are going to add some colorings to it before, when something is colorless and the mercury level, change in the liquid level. If it's like water, alcohol is as colorless as water. Water in glass now, you might not be very sure that the level is changing. But once it is something that is silvery in color, you'll be very sure with the change in temperature, with the change in the color, in the movement rather. So it's going to change its level. If it was here before, changing to this place, you are going to see it clearly that it has changed. I'm going to see it clearly that it has changed. So it is silvery in color. Another one is that it measures higher temperature. It measures a higher temperature. It has the boiling point of about 318 degrees Celsius. That's mercury. A higher temperature. So it is very sensitive, very sensitive. That means the thermal conductivity is high. I said thermal conductivity is the ability to conduct it very well. So the thermal conductivity is high. But alcohol, thermal conductivity is quite low. It is organic, not really sensitive. And alcohol cannot measure too much temperature. It will vaporize. Alcohol cannot measure very, 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 very high temperature. It will what? Vaporize. It will vaporize. You can't measure very high temperature to vaporize. While this one can measure very high temperature, it will not vaporize. So, but as the reverse case too, this one cannot measure very low temperature, while alcohol will be able to measure it. That's how it goes. This one will freeze for very low temperature, while alcohol will not freeze. Vaporization means turning to gas from liquid. Freezing means turning to solid from liquid. So, okay, 10:05. Let's start by 10:10. Constant volume gas thermometer. Thermometer that is quite cumbersome. Jolly was the first one that did it. Yeah. When calendar did it. So Jolly, yeah. Someone. So the constant volume gas thermometer has its own thermometric substance to the gas. The gas is either hydrogen or helium. This one, the liquid is either mercury or alcohol. This one, the gas is either hydrogen or helium. So the thing works with the principle of pressure and temperature according to the pressure law. When the temperature is high, the pressure also increases at constant volume. So once there is a change in the pressure of the material, you know that the temperature has changed. If it increases, pressure also increases. That's how the constant volume gas thermometer works. While metallic thermometer works with the principle of expansion. Different metals, two different metals. That's why they said bi-metallic. Two different metals, like brass. Brass is an alloy, and iron. They have different expansivity. The brass is like this now. Yeah, the brass is here, iron is here. So when brass starts to expand, it's going to expand to this level, while iron still expands to this level. So the change is going to be the one significant for it, or responsible for it. The significant change will be the one responsible. Thermocouple also uses two dissimilar metals like copper and silver. This one works with a flow of current between them. While resistance wire thermometer uses platinum wire is the resistance wire. According to the Ohm's law, the stuff that affect ohmic conductors, platinum wire is ohmic. So when the temperature increases, the resistance also increases. So the thing will not be able to conduct electricity very well the way it was conducting it. So these are the thermometric substances. The coordinate, state of coordinates are the length of the mercury, the pressure of the gas, the expansivity, the potential difference, and the resistance. So I think we can take a break there and let us move in the next class. The next class will be a calculation class or calculative class. So may God help everyone. Have a nice time, everyone. Thank you. Anyway, I should come again.
Yes, yes. Like that liquid in gas plus thermometer. What does it use?
I said the state of coordinates. That state of coordinate is the property of that thing that makes it to be possible to measure temperature change. You know, the property of mercury here now that makes it possible for you to measure the temperature change will be the volume or length of that mercury thread in this thermometer. So the same thing for alcohol. The length will increase when the temperature increases. So that length is the state of coordinates. The volume, constant volume gas thermometer is having hydrogen or helium. So when the pressure increases, when the temperature increases at constant volume, the pressure will also increase. That means the pressure increases with increase in temperature. Then the pressure is the state of coordinates. Bimetallic thermometer, it works with expansivity. So the state of coordinate is the linear expansivity of the materials there, the coefficient of linear expansivity. Thermocouple works with the principle of potential difference. Yeah, we have two different junctions. So when the temperature is high, potential difference is very high too. So when the difference in the temperature, there will be cold junction, there will be hot junction. Cold junction will have ice. Hot junction will have any temperature, maybe 100 degrees Celsius. So the higher the difference in temperature, the the potential difference produced. They are using the galvanometer to measure the potential difference there. So resistance wire thermometer, that's platinum wire. So the higher the temperature, the higher the resistance. That means the lower the ability to conduct electricity. Resistance is the opposition to flow of current electricity. So when the resistance increases, the electricity flow reduces. So that means the resistivity of that platinum wire is its ability, is its state of coordinate. So thermocouple, this one is just something you can read. We've explained it. It's something you can read. That's why I'm not wasting my time on it actually. So if it's calculation, I'll definitely explain very, very well. Like we'll take it and I won't be rushing. But this one now, just take it as you've heard of it already. So God will help everyone. Have a nice day.
Okay, to the next class. Your next class will be calculations. Have a nice day.